When people first look at a shipping container build, the process can seem straightforward. A steel structure, a piece of land, a few openings, and then the rest is just construction. In practice, though, this type of project rarely begins with construction itself. It begins with a network of variables that all have to align at the same time: suitable land, delivery access, local requirements, container selection, layout decisions, foundation type, and construction sequence. That is why before any steel is cut, the project is already functioning as a system. Each decision affects another. And when that is not recognized early, the process tends to accumulate small incompatibilities that only become visible later, after time, money, and planning have already been committed. In many cases, the first approach is to treat the build as if it were a simplified version of a conventional house. The logic seems direct: buy the structure, bring it to the site, and adapt the rest. Another common approach is to start with the appearance, the floor plan, the exterior look, the number of modules, before checking what the land actually allows. It is also common to focus almost entirely on the price of the container itself, as if the unit cost were the main indicator of the entire project. These approaches are understandable because they simplify the beginning. They reduce the sense of complexity. But they also hide the fact that the container by itself is not yet a house. It is only one part of a larger chain. When a project begins with isolated pieces rather than the full picture, friction usually appears later: difficult transport, structural adaptation, permit issues, layout revisions, or a mismatch between the plan and the site. The central limitation in this kind of build is that almost everything depends on something else. The container has fixed dimensions. The land has its own constraints. The steel structure responds in specific ways to cuts, openings, and reinforcements. Delivery requires physical access. The foundation has to match the soil and the final layout. And local approvals may impose conditions that change the timeline. This creates an important characteristic. The project does not move in a straight line. It moves through dependencies. Each stage acts like a checkpoint rather than a simple automatic sequence. Because of that, an error that looks small at the beginning can become structural later. A site choice can limit the floor plan. A floor plan can require a different reinforcement strategy. A reinforcement decision can affect cost. A cost change can trigger a revision in materials or scope. The result is a process in which the house is not just built, it is coordinated. This chain-like nature is also why different formats exist for approaching the same kind of build. Some people use a traditional approach, with professionals handling most of the work. Others choose hybrid models, combining their own labor with outsourced stages. There are also prefab systems, kits, and modular plans that attempt to reduce variability in the process. Each format responds to a different type of organization. Some reduce construction risk, some reduce coordination demands, some try to simplify decision-making before the build begins. In the case of shipping container homes, this variety exists because the original problem is not only construction, it is aligning technical, logistical, and regulatory decisions within a very specific structure. When that happens, the question is no longer just how do you build a house, it becomes how do you organize a set of parts that depend on one another. In that setting, organized guide-based materials appear as one possible response to the complexity of the process. One example is Shipping Container Home Made Easy, presented as a reference system for people dealing with this kind of build. It enters this context not as a shortcut or as a guarantee, but as a format that gathers stages and criteria around a problem that is, by nature, fragmented. This type of product tends to exist because the subject requires coordination before execution. Rather than treating each decision in isolation, it offers a unified reading of the process. And that explains why this market often revolves around checklists, modules, sequences, and comparison criteria. The challenge is not only the build itself, but the management of the dependencies that come before it. In the end, a shipping container build is not defined only by the steel structure that arrives at the site. It begins much earlier, at the point where the variables need to be aligned. Land, transport, layout, approvals, structure, and foundation are not independent stages. They are parts of the same system. And when a project is understood that way, it stops looking like a single task and starts looking like a set of connected decisions. That is why, in this kind of build, the first question is usually not, how do you construct it? The real question is, how do you make everything work together at the same time?